So first of all, good morning, everybody. So welcome to Munich. And today we will have a fast track on Qt. So I would like to introduce to you the Qt framework. So first question to you, who is already familiar with Qt? Hands up. And who is new with Qt? Okay. So today we will focus on the framework, and I will show you some exercise. Unfortunately, the time is not enough to do all the labs today, and we are too many people to do the lab exercises. So I will show you some exercises, but a normal training, as Kevin already said, would have the hands-on lab so that everybody brings his laptop, but feel free to follow the exercises on your laptops as well. So let me just introduce myself. My name is Oliver Gutbrod. I'm working for a company, Widgets, which is a certified partner with Qt for the past 5 years. So Widgets is a company, software company, offering all software services and mainly focused on Qt. So we are Qt specialists and have a lot of experience with Qt, and we offer consulting, programming, and training. And we also have a lot of customers where we write tailor-made software for them. So whenever you like to see more details about our companies, just feel free to visit our booth at the exhibition area. There is nice demos we have, 3D animation with robots. We also can show you some Qt on Android programs. Really nice stuff. So the training course today is split into 2 parts. First of all, we try to learn about the fundamentals of Qt, where Qt comes from. We will learn how the objects in Qt will work so that you have a basic impression on Qt objects. And we will learn about core classes in Qt. So very important classes like strings and container classes. So that's all your daily work with Qt. And in the afternoon, we try to focus more on the user interface side. So in Qt, everything is called a widget. So we will mainly focus on Qt widget. We will create some demo applications and showing you the main features of an application, like main windows, settings, and resources, and so on, so that you will have the knowledge how to create your own applications. Okay, so let's start with the fundamentals of Qt. In this chapter, I will show you how to develop your first Hello World application with Qt and give you some practical tips how to develop applications. So here we see the objectives of the session. So we will learn about the history and the ecosystem of Qt. We will create the Hello World program, and I will show you how you can do this with Qt Creator, which is an IDE which helps you on all the platforms you target. So the story of Qt is it was founded in 1994. So the main idea was to have one framework on different platforms, mainly on Windows, Linux, and Mac OS, so that you write one source code and you can target different platforms. And nowadays, so since Nokia acquired Trolltech in 2008, it's also mainly focused on embedded and mobile platforms as well. So you can write one code and target multiple platforms. So here is a short slide about where Qt is used. So I'm sure you know some of the companies using Qt. So I think everybody knows Skype, and lots of companies using Qt today. So since Qt was released under 2 licenses, there is an open source license available under GPL and LGPL, and there is as well a commercial license. So, and this has a large ecosystem, so the open source community is quite big, giving a lot of feedback, so how to make Qt better. So a lot of programmers using Qt. So why should you use Qt? So as I already said, you just write your source code once and you can target multiple platforms. So may I ask you a question? Who is using Windows and Linux, Mac? And who is developing embedded and mobile applications? Okay, so we have all of them. You just write one source code and you can target nearly everything. Okay, so since many people using Qt, you have a lot of information available in the internet, and you can also find very easily support, training, yeah, as you have on the DevDays here, many people you can ask for your problems. So here we see the Qt architecture, and let me show you how the Qt framework works. So Qt is split into different modules. Of course, all of your applications will use the Qt core classes. And if you have a GUI, which mainly all of your application will have, you can use the Qt GUI module. And then there is some additional modules available whenever you want to have a browser engine. You can use the WebKit module. Or if you want to have some fancy graphics stuff, you can use the graphics view. So a lot of functionality available in these modules. So, and before we go too deep in these modules, the goal is that Qt is separated into different modules, and you can just make a check mark and say, I would like to use this and this and this module. And Qt framework will take care of building everything for you. So in the orange box, you see all the platforms which are supported. We have the 3 desktop platforms, Windows, Mac, and Linux, and also the embedded platforms like embedded Linux, Windows CE, of course, Maemo and Symbian. And there is also a port available for Qt on Android nowadays. So how can we use these modules? Of course, we need some development tools. And today, I will show you the Qt Creator IDE, which is a cross-platform IDE which you can use. So this IDE is the same on Linux, Mac, and Windows. So you don't have to care on which platform you're developing. There is a GUI designer available to design your user interfaces. And we will see this Qt designer in the afternoon. There is a help system available. So whenever you want to look into your classes, QAssistant will show you all the information available in the Qt framework. So nowadays, most of the applications are international, so you need multi-language support. There is a tool available called Qt Linguist, which helps you out in how to translate your applications into multiple languages. And of course, the last one is the most important one. We need a cross-platform build tool to make everything working on different platforms. Okay, so before we go into our first application, I would like to show you some demos. So whenever you install Qt, you will find a demos and example program within your installation. So here, when you download Qt and install it, you will find examples and demos. So let's just start it. And here you find some demonstrations about all the modules. So if you're interested in some parts of Qt, you can just browse through all these topics and have a look at the demos. So let's try to find a fancy one. So this one is nice. So it shows just an example about how to use graphics view. And we see this demo in action. We just have some colliding mice. So you see the mice are moving around, and whenever they collide, they get these red ears on collision. So the good thing about all these demos is that you can have a full set of documentation available. So just click on this documentation. Qt Assistant will open up, give you all the information about an example. And if you just click on the files, you can open the source code, look into how this demo works, and copy and paste the source code into your application. So that's always very helpful in the beginning. So just feel free to play around a little bit if you have the demos running on your systems. So there's also some fancy animations here using the Qt animation framework. So many topics available here. So it's but the time is too short today to go deeper into the demos. Okay. Okay, so let's try to create our first Hello World application using Qt. So on this slide, we see a very simple application. It's just a main function having 4 lines of source code. And whenever we compile that, we get this application running. We have a main window with a Hello World button in it. So within the main function, we just create an application object. With type QApplication, we create a button with the caption Hello World. We show the button, and at the end, we call app.exec to run the main event loop. I think this is quite common for all of the platforms. So our program just consists of a main.cpp, which is our source file, and we have a project file. And the project file is needed to tell Qt what kind of source files we have, what kind of header files we have, and all the information what is needed for this project is within the .pro file. So and then we need some build tool to create a cross-platform makefile out of it. So and this tool is called QMake. So in QMake just gets this profile and transform this in a platform-specific makefile. Okay, so let's try to run this. So to understand what is going on behind the scenes. So whenever you install the Qt framework, on Windows we will have a command prompt for Qt 473. So what does it do? It just sets some environment variables for us and tells us which version of Qt we are using. In this case, it's C Qt 473. And then we go to our project directory. And I think you all got a USB stick where you can find all the slides and examples on it. So you will also find this add-on directory where all the examples and labs are located. And within this add-on directory, we will find directory fundamentals. It's the example Hello World. And within this directory, we just have our main.cpp and the project file. So when we now call QMake, QMake will generate the make file for us. So this is the first step. And the second step is that we can now compile this platform-specific make file. I'm using Microsoft compiler on my system, so I have to type nmake to get everything compiled. So let's just rebuild everything. And you see that nmake will now compile the main.cpp, link everything, and create the executable. Okay, but doing it all in a command prompt is very tedious. Normal programmers, they would like to have this within an IDE. So let's do it using Qt Creator. So Qt Creator is a cross-platform IDE which mainly has the basic functions for an IDE where you have a source code editor with full-featured functions like code completion. So we will learn the Qt Creator today, and it has all the functionality for debugging, watching variables. So everything is built in Qt Creator. And this is how Qt Creator looks like. So on the left side, we have a mode selector where we can select the different modes. So here we're in the edit mode. We have the project tree with all the files within our project. And on the right side, we have our editor area where we can edit our source code. So whenever we are finished with editing, we can run or debug or build our application. And we have the different views for the compile output, the application output, the build issues, or the search results. So Qt Creator also offers us the possibility to find something very easily. So we can use the code locator to find the class, go to a specific line, so which makes it very easy to navigate through our project. So especially for large projects, it can be very complex. So the good thing is that you can just click on a symbol in Qt Creator and just find the usage of this function or go to the definition. So it automatically jumps to the place where this function is defined. Yeah, today we will also see how to debug our application. So we just set some breakpoints. We can run the application. And when we enter a breakpoint, we have a watch window where we can see all our variables and debug it. So let's try to do the Hello World application using Qt Creator. Just taking a time to start it. Okay, so here we are. We have an empty project here, and now we would like to create a new project with the file new. So we select a Qt widget project, and here we would like to have a normal Qt GUI application. So we can just specify a project name and a directory. And now Qt Creator leads us through the next steps. So we would like to target the desktop, and we would like to create the build configurations, in this case, for all the Qt versions which we have installed on our system. We can specify the class names and define the base class of it. In this case, we can just say it's a widget. And we would have our first application, and without modifying anything, we can compile it. So let's take a look at the compile output and run it. And you see, we now have our first application using a main window. So that's it. So let's try to implement the Hello World application which we have seen before. It's nearly the same here. So whenever we try to enter a function, you will get a list of available constructors here for this QApplication class. So and with the up and down keys, you can just have a look in how many constructors are available for this QApplication class. Okay, let's try to include the QPush button. So it also offers me the QPush button here. So I just enter. Okay, so let's try to run it. And you see we have our Hello World application with a push button which has the text Hello World. So just these 4 lines of code. So when we would like to debug our application, we just set a breakpoint by clicking on the left space here. So we have a breakpoint, and we can just debug our application. So when we run it in debug mode, we stop at the breakpoint, we see the call stack where we are, and we see all the variables in a watch window. But I think this is pretty common to all the IDEs. So that's just daily work. But the good thing about it is that it looks the same on all the different platforms, and you only have to learn one IDE. Okay. So if you have any questions, don't hesitate to ask. Okay, and here are some practical tips for you developers. So how much C++ do you need to know? Who is familiar with C++? I think nearly all of you. Yeah. So of course, you have to deal with objects and classes and have to think about inheritance, calling member functions. You have to think about polymorphism, so which is mainly virtual methods you have to use. You have to deal with operator overloading whenever you need that. But you don't have to deal with templates normally. So the only thing which needs the usage of templates is the Qt container classes, which we will learn in the core classes today. You don't need to know about runtime type information, RTTI, because Qt has its own way of doing that. You don't have to think about sophisticated templates and exceptions. So let's take a closer look in the Qt documentation. So we already seen a brief look into Qt Assistant. So when we go back to our Qt creator, you see a help button on the left side, or we can just select something here and press F1. And an integrated Qt Assistant will open up, showing us all the help available for Qt application class. So you see all the properties of the class, all the functions. You see about the signals and slots, which we will learn in the next chapter. And you will find a detailed description on how to use this class. So Qt help system is really big, and you can find a lot of information about the classes you would like to use. But it's not only Qt Assistant where you can find answers on your Qt problems. We already had the examples and demos, but there is also many informations available in the internet. There is forums where you can look at. I think some of you know the KDE project, which is completely based on Qt. And because KDE is also open source, you can take a look in the source code of the KDE project and find lots of programs and source code available for you. And if you try to look into source code from somebody else, the Qt source code is mainly very easy to read. Of course, there are some exceptions to that. But normally, if you see some Qt source code, it's really easy to get through some sources from somebody else. Okay, so how can we make use of the different modules? So as we have seen in the Qt architecture slide, there is different modules available like Qt Core, Qt GUI, Qt XML, and we would like to use this functionality within our application. So everything has to be specified in the project file, and this is done using the Qt plus equal operator. So if we specify the Qt plus equal network, it automatically has the network functionality, and Qt will take care that this module will be linked into your application. The only thing you have to do is you have to include the header files within your application, and you can do this in different ways. As you have seen in the Hello World example, I included the Q push button to make use of the push button itself. So in this example, we have a Q label, which is mainly a text label, and if we like to use that, we just include Q label. Or we include Qt GUI Q label, which is mainly the same. Or we can include the hello module. So let's say if we are using different Qt widgets like a label, a combo box, a push button, and so on, it might be easier to use the Qt GUI module in total. So the different ways of including functionality has advantages and disadvantages, of course. If we just include some tiny parts of it, like a Q label, it's better for our compilation time, because it just has to include the tiny parts of Qt. If we include the whole module of Qt GUI, our compilation time increases, of course. But whenever our operating system and the compiler supports precompiled headers, we can pack everything in a precompiled header and just compile it once. But that also means whenever you're touching your precompiled headers, it has to recompile all the precompiled headers, so which can take a long time if you have huge precompiled headers. So a good approach for including classes is that you include, for instance, the Q label within your CPP file, and within your header file, you just use the forward declarations, which is class Q label. So the compiler knows that Q label is a class. And if you are only using pointers to this class in your header file, it will compile. So coming to the first Q&A session of today. So I would like to ask you some questions. So what is Qt? And I would like you to pass the microphone. So who wants to answer this? It's a pretty simple question. Nobody? So Qt is just a cross-platform framework, a C++ framework with a lot of functionality and targeting different platforms like Windows, Linux, and Mac OS. So, second question, which code lines do you need for a minimal Qt application? Any volunteers? maybe you wait for the microphone.
The include statement in the instantiation of a object.
Okay. Yes, so we need to instantiate an object, which is mainly a Q application object. In our example, we had a top-level widget, which was a push button, or it can be something else, so that we show some widgets on the screen. And at the end, we have to execute the event loop, which we do by running QApplication exec function. So what is a .pro file? Yes, it's mainly a Qt project file with all the information needed for your project. Yes, you can also specify multiple targets. So you can tell, if we are running on Linux, I would like to have this and this libraries on Linux, and on Windows I would like to have this libraries included. So everything goes into your profile. So what is QMake, and when is it a good idea to use it?
Compile a Qt application.
Yes. You want to repeat that with the microphone? So because the session will be recorded.
To compile a Qt application or project.
Yes. So QMake does all the work for you. QMake is the utility to create your cross-platform makefiles out of your project file. And when is it good to use it? Normally you don't have to deal with that because everything is done automatically using Qt Creator. What is a Qt module and how to enable it in your project? So let me answer this question. Yeah, a Qt module is a set of functionality like XML support. So we have to specify this in our project file with Qt plus equal XML in this case. And we want to use the functionality within our source code, we have to include the specific header files of this module. How can you include a Q label from the Qt GUI module? So there's different, any volunteers? There's different ways of including it. We can just include the Q label, or we can include the Qt GUI label, which is the same, or we can include the whole Qt GUI module. Name the places where you can find answers about Qt problems. That was on some of the previous slides. We have the Qt Assistant, the demos and examples, and we will find lots of answers in the internet. So just Google for it. Okay, so any questions so far?
Yeah, I got a question about the PRO file. What does it contain? Just a project to compile and link, just a DLL or an exe, or a really whole project consisting of different DLLs plus an exe?
So it contains all the information of your project. So this is the source files, the header files, all the libraries you need to compile and link your project. And it can also contain the different information for different platforms.
And it really contains a whole application consisting of different DLLs and other stuff.
Yes, you also have to specify what kind of target it is. Is your project a DLL or a library you would like to create, or is it an executable? Everything is specified in the profile. Okay. So let's take a look into Qt objects. So in this chapter, we will learn all about the common features of the Qt object model. And normally, most of your classes will be derived from QObject. So what is the benefit of deriving from QObject? So you can use functionalities like signals and slots, which is used for inter-object communication. Or we can use the Qt event system on how to create events within your objects. So what will we learn in this chapter? The Qt object model is a hierarchical structure of parent and child relations. And we will learn how widgets are derived from objects, and we will learn how to combine these widgets. Then we add some signal slot functionality to our objects so that the objects can communicate with each other. So what is the base functionality of a QObject? So it adds some extra features to your C++ classes. As we said, signal slot for communication, or we can define some properties to your classes. We think about the memory management and how we can simplify a life cycle of our objects, because we don't want to create memory leaks within our application. So Qt will help us to avoid memory leaks. So and some of these features are standard C++, and everything which goes on top of C++ is using the Qt's meta object system. And I will show you what this means. But keep in mind that a QObject has no visual representation. It's just an object in memory. So how to organize the objects? As I said, we can create a hierarchical tree structure with our objects. And we do that by specifying a parent at the creation time of a QObject. So whenever we create a new object, we can specify the parent. So the default implementation is a null pointer, which means that this object does not have a parent. It's a top-level object. But whenever we specify a parent, this parent gets the ownership of this newly constructed QObject. So for instance, we see that in this small tree. So this object is a child of this parent object. So, and then it's very simple. So when we destroy the parent window, or the parent object, this parent is responsible for all the children. So it will first destroy all the child objects before it destroys itself. So in that case, whenever you create objects attached to a parent, you don't have to care about the deletion, because Qt does it for you when you destroy the parent. Some note at the bottom, parent-child relation is not inheritance. It's just an ownership. So Qt also takes care that no object is deleted twice. So you don't have to think about that. So how do we do this in our source code? So let's take a short example here. So mainly we create the Q objects on the heap using the new operator. So in this case, we create a new Q label with some text and we specify a parent. So the second approach would be to create the objects on the heap. So which we do when we are using local variables. So in that case, there are some examples for creating objects on the heap, which is a Q file, for instance. Or you have seen the Q application within our main function. This was also created as a local object within our main function. So that's created on the stack. And typical classes to create on the stack is a Q string, or Q string list, Q color. And the rest of your objects, mostly all of your widgets, are created on the heap using the new operator. So in this case, creating it on the heap, Qt will take care about the deletion if you specify a parent. Or you have to delete them yourselves within your source code. It's up to you to delete the objects at any point of time when you want to do that. An example would be you have an application object, which is the lifetime of your application is all the time when your application is alive, and you attach and attach and attach to your main application. So your main application will never get destroyed until the user closes the application. So you have to think about memory consumption, and you may want to delete the child objects yourself. So in case on creating the objects on the stack, this is pretty simple. The objects are deleted whenever your variables go out of scope, which is at the end of your function, the destructor gets called. So let's take a look on a Q widget. What does a Q widget have to do with a Q object? And the answer is it's derived from Q object. So Q widget inherits all from Q object, and it adds some visual representation on top of your Q object. Then Q widget is the base class for all your widget-based UIs. And QWidget handles all the input events like mouse events, keyboard events. And of course, it will also implement the paint functionality. So in this example, we see that all the widgets like QLabel, QPushButton, TextEdit are derived from QWidget, and QWidget is derived from QObject. So which means the creation of QWidget is more or less the same as the creation of a QObject. You can also specify a parent for each widget. And if you do not specify a parent, that means your widget is a top-level widget. So in your operating system, that will mean it's a real operating system window, a top-level window. And then you can attach some child widgets to this top-level widgets just by specifying the correct parent to your widgets. And that also means that whenever you attach a widget to a parent, that this widget is alive in the parent's coordinate system. In the top left position is the 0, 0 coordinate. Then Qt automatically takes care about clipping. That means that your child widgets are not painted beyond the border of your parent. So you can just paint within the parent's bounding rectangle and not outside of it. So QWidget also propagates the states to the children, which means if you hide a parent, automatically the children are hidden. If you disable a parent, all childs get disabled as well. So Qt also maintains the states of each widget individually, which means if you have disabled a child window and you disable the parent and enable the parent again, your child is still disabled, of course. Okay, so how can we construct the widgets within other widgets and make your widget look good, and we don't want to take care about repositioning of our childs? So Qt offers you some really nice layout functionality. So in this case, we have some helper classes, which is, for instance, a horizontal box layout or a vertical box layout. And in this case, we have a label, a text edit, and some buttons. So the main layout is a vertical layout, and these buttons are arranged in a horizontal layout. So let's take a look at the example. So we just create a top-level widget, which is called container. Here we do not specify a parent, so it's a top-level widget. Then we create some child widgets, a label, a text edit, and 2 buttons. And then we arrange everything in a layout. So in this case, we have 2 layouts. So one is a horizontal layout for the buttons, and you see we add the clear and the save button to this inner layout. And then we have an outer layout where we just add a label, an edit box, and the inner layout to have the result here. So let's take a look at this example. Where is it? It's called X Simple Layout. Okay, I just click on Finish, taking the default settings. It's pretty simple. It only has a main.cpp with a main function. And when we run this application, we have a top-level window with this child widget, and Qt now automatically takes care of positioning these widgets correctly. So which means if we resize our top-level window, all the children get repositioned correctly. So you don't have to take care about this. Qt does everything for you. I think we quickly go through the next Q&A slide. What is an object tree? So it's a hierarchical structure of objects which have a parent-child relation. So which pointers to QObjects do you need to keep around? So this wasn't mentioned explicitly, but it's C++. Whenever you try to access your objects within a member function, you should keep a pointer to your QObjects. And we will see how Qt handles this automatically whenever you create your own UI files. What does it mean when a widget has no parent? It means that it is a top-level window. Now let's just ask you some questions on how to allocate these clauses. So would you create a Q widget on the heap or on the stack? Who is for heap? And who is for stack? Yeah, it's on the heap, normally. A string list, heap, stack. Okay, it's on the stack. Q application, heap, stack. Yeah, here you can do both. Mainly it's on the stack within your main function. Q string, heap, or stack. Yeah, stack. And Q file, heap, or stack. Yes, stack, normally. So name some layout managers and when to use them. So on the previous slides, we just had the horizontal and the vertical box layout, but there is some more available. And you should always use them whenever you want to have a layout manager responsible for rearranging your widgets on the screen. So nowadays, most of the applications are multi-language supported. So that means a push button can have a very long text, for instance in French, and you would like to use this button so that it automatically calculates its width based on the text within the button. And here it's really good to use a layout manager because it handles all these calculations for you. And what does it mean to nest the layouts? So we have seen the nested layouts in the example. So we can, for instance, create an inner layout within an outer layout. And we can do that in a hierarchical structure. We can just create a vertical layout, and then in that a horizontal layout, and within this horizontal layout, maybe the next vertical layout. So it's all up to you as the user interface designers. Okay, so we will skip this lab, but you will find all the source code on the USB stick you get. You will find the starting point within Objects, Lab, First App, and there is also the solution available on the USB stick. Maybe that's some good homework for you. Okay, so let's try to see how the objects can communicate with each other. And we can do this in different ways. So possible solutions are callback functions. I think every one of you knows about callback functions. And I think every one of you using callback functions had the problems that your application will crash if you just do something wrong. There is no type conversion, no nothing, and it can be really unstable. You can also implement an observer pattern where you have a publisher and a subscriber. But this is also a lot of work to do because you have to register and deregister for your specific events. And Qt uses signals and slots for high-level semantic callbacks. And it uses events for low-level semantic events. And we will see what the difference is. So the signals and slot communication provides a type-safe callback. So you cannot do any harm to your application. Let's say if you just have a string on one side and an integer on the other side, your application will not crash. It might not work for this connection, but it will not crash. So let's do some example on how to connect two objects. And it's a pretty simple example. On the left side, we have a slider, and on the right side, we have a spin box. And whenever the user moves the slider, we would like to update the spin box. So whenever the user changes the value of a slider, a signal gets emitted, just telling us the new value of our slider. And on the right side, we implement a slot, which will just update the new value within our spin box. And the thing in between to connect these two objects is a signal and slot connection. So what does it mean? We have to connect these two objects using the connect function of the QObject class. And we specify the sender, the signal, the receiver, and the slot. So in that case, we connect the slider signal value changed, which has a parameter int, to a slot of the spin box, which is called setValue, and also has a parameter int. On the sender side, we have a place where we have to emit the signal. In this case, when the user moves the slider within our mouse press event, we emit the value changed signal with a new value. And on the receiver side, we just implement a slot where we just set the new value and update our control. So in these three things we have to follow to create a signal slot connection. It looks more complicated as it really is because the slider is already available within our toolbox. So somebody who has developed the slider object already thought about the implementation of a slider. The developer who implemented the spin box already thought about the functionality and implemented the setValue slot. And the only thing to combine these two elements is to use the connect within our application. So. Okay, one example for the signals and slots is we have our hello world executable again. And when I press this button, I get a debug message that a specific slot is called. And how do we do that? By just telling we have an emitter, which is mainly our push button. We have a receiver, and within the main function, we just connect this emitter signal to a receiver slot. So this technique of signals and slots is quite common within all the Qt framework. So this is some fundamental design we have to know about. So because all of the QObject derived classes can use signals and slots. And that's what you saw in the Qt Assistant. Each class information within Qt Assistant has some signals and slots definitions. And you can see a slider has a value change signal, which I can use. Okay, so what do we have to do to make everything work within Qt? We have to implement a slot where we derive our class from QObject. And then we have to tell Qt that it is a QObject So that's something we do with the QObject macro here. And we will see what Qt does with this macro. And then we can just specify the slot within the class, which is mainly a normal function call. And on the implementation side, this just looks like an implementation of a normal function. So here are some examples on how to use slots. For instance, you can use the Qt timer, which just has a timeout signal. You can just connect to this timeout signal and say, every 1,000 milliseconds, I would like to call the slot. Or you can just call a single slot, a single shot function, so that this timer is just executed once. So the signal side is also pretty simple. The declaration in the header file looks more or less the same. We also need the QObject macro to make use of the meta object information. And then we specify the signals with the signals keyword. So it also just looks like a normal function. So whenever we like to emit the signal, we go to the implementation of our class and just call the emit of this signal. So what is done in the background of the meta object information system? So because signal and slot mechanism is not available in C++, we need something on top of C++. And this is called the meta object system. And we have an extra compiler for the meta object information, which is called mock. And whenever you compile your applications using meta object information, you will see that some additional compilation steps will be executed. And QMake automatically takes care of everything. That means whenever you specify the QObject macro within your header file, everything is done automatically for you. But whenever you see some extra files called mock underline something.cpp, this is the meta object information system. So back to our main problem, how can we react on a button click? And we already saw this in the example. We just connect the button clicked signal to a slot handling this action. So pretty simple. Okay, so let's skip this lab exercise. There's some variations in signal slot connections, which makes it really simple. So let's assume you have your slider and you would not just want your spin box connected to that. Maybe you have a second spin box or edit field where you want to update the same value. So you can connect many slots to the signal. Whoever is interested in the signal can connect to it. Or let's take another example. Let's say you have an update slot and you want to update specific parts when a signal A comes or when a signal B comes. So you can also connect many signals to one slot. Of course, that's possible. And a third way for signal and slot connection is that you can connect a signal to another signal. So maybe you are within a queue object and you have a child object and you want to propagate the signals. You can just say, when my child has emitted a signal value changed, I would like to also emit a signal value changed or something else. So then you can connect a signal to a signal. Okay, so how can we make a connection with different parameter types? So when we have a range change with two parameters of type int, of course we can connect a slot with two parameters of type int. We can also connect a set value slot which only has one int. So this int will be connected to this. And this second parameter is just discarded, not used. And the third way is that you don't have any parameters within the slot. Then the two ints in your signal will just be ignored. So the same is for this value change. This is both okay. But if you have an int in your signal, you cannot connect it to a slot having two ints. Because what should it use for the second parameter? And it also does not do a type conversion. Also, type conversion within here is not possible. But a clicked signal to an update UI will be possible. And the last one is not possible. So to avoid these problems, you can specify default parameters. In this example, you can say the set value int, the default parameter is 0. So int I equal 0 will work for this connection using default parameters. Okay, so I would like to skip this Q&A because we have 3 minutes to 12, another lab. And I would go ahead with the event handling after the lunch break. So any questions so far?
So when I connect many signals to one slot, do I have to take care about thread safety by myself then, or is it done by the framework somehow?
You are asking about multi-threading.
Yes, because many two signals can arrive at the same time, for
Yes.
example. And
Yeah, normally you don't have an influence on the order, which receiver is called first. And if you're running on different threads, it will not be a direct function call. Everything will be packed in an event, and this event will be posted to the receiver thread. So, but this is something which will go into the multi-threaded programming course.
okay, thanks.
Is there a way to check the correct parameters of the signals and slots?
So the question was if there is a way to check the parameters. And the answer is the connect function will have a return value, which is telling you whether the connection has succeeded or not. So it's always a good thing to make an assertion around this return value so that you immediately see that the connection failed. Otherwise, if you don't do that, the program will just continue, but your signal slot connection has not been established, and you will not see that immediately. What you will also see is we have a debug output window within Qt Creator, and whenever a connection fails, you will see a debug message in the debug window that this connection failed, and it will also tell you if the slot is not available and tells you which file and line number it is.
So it's only at runtime?
Yes. It can only be checked at runtime because the connect function will only be called at runtime. Okay, so one more.
I have another question to the hierarchy of widgets. Sometimes I might find it helpful to have a member pointer to a specific widget. Is this a bad design? Because I never know when they are destructed. Or is there a way to
Yeah,
find
I
when they
know.
are deleted?
There is a way to do that if you use guarded pointers. So whenever you want to get notified about the deletion, you should use guarded pointers. So there's some help clauses available. Okay, so one more, then lunch break.
Thank you. I just got one question. That is, if I have a signal with 2 parameters, can I somehow force it to use the second parameter if I connect it to a slot with only 1 parameter?
Can you make an example?
A few slides back, you showed a few more. Yes, there. We have the range changed int, the first one.
Mm-hmm.
And you said you could connect it to the set value int, and it would automatically choose the first int from the range change. Is there a way to force the second?
No, that's
Okay.
not possible.
All right, that's
No.
it. Thank you.
The order of the parameters is always,
All right.
you have to keep on that. Okay. If it is a short question,
It's unfortunately not so short. Is the signature always, at least in the Qt framework, is it always int, just a row of ints, or
what do you mean, the parameter types?
the parameter types? Yeah.
It can be any kind of parameters, and we will see what we can use. We can not only use the predefined like int and strings, we can also define our own user-defined data types for signal slot connections.
Yeah, and the functions I find in the framework, is it typical here with what we see here?
Yes, it's always good to use basic data types because it increases the reusage of your component. If you have a very special structure which is emitted within a signal, so it might not be so reusable for someone else. So it's always good to use basic types. Okay, so let's close the session now and have lunch break and continue at 1 o'clock.